I think I hope that you are practicing chapter Unit 1 sums also. That you are
Yeah,
on the
yeah.
way to it. Yes. Okay. So today is class 18, Unit 2 we have started. Yesterday we have seen something, 2 to 3 topics about Unit 2. So first of all, we'll get a revision into it. My video is loading. Just a minute.
Hmm?
If
That's
I'm
fine.
changing my abstract. Okay. So in yesterday's class, we had in Unit 2, we had started with a relation between two categorical variables, a relation between
Yeah.
two categorical variables, and we have seen there is there the relation can be described as association, association between these two association. So there can be a positive association, negative association, and well as
Hmm.
no association. Yes or no?
Yeah.
Yeah. So now, while we are studying association, there comes a study of association, which is known as correlation, which is known as correlation. So I think we had stopped here. So I'll just revise about correlation. So what is the thing? Okay. So
Wait, can you give
measuring
me
of
1 minute real
association.
quick?
You want a break? 1 minute?
No, just 1 minute. I need to go to the
Yes, yes.
bathroom.
Okay, okay, okay. Go ahead.
Okay, I'm back. I'm back. Hello?
Okay, okay. So I'm back here, right? Okay. So
Mm-hmm.
measuring of okay. Measuring of association, measuring of association, measuring of association is called as correlation. Okay. So
Mm-hmm.
correlation has a symbol R. Okay, and correlation ranges between -1 to +1, -1 to +1. So for I've told you yesterday for positive
Mm-hmm.
correlation it's +1. For no correlation it's 0, and for negative correlation it's -1. Okay. So if it is exactly +1 or near about +1, it is strong. Okay, less than 0.7, it is moderate. Around 0.7 to 0. You can say 4, it is moderate, and less than what you say 0.3, it is called as weak. Same as with minus things here. -1 is strong negative. Okay. -0.7 to -0.4, it is moderate, and then below -0.3 it's weak. Okay, and no correlation means when there is a zero value, then we say as no correlation. Okay, so correlation generally measures the relation between the x-axis and the y-axis, and we have seen yesterday that on the x-axis the exploratory variable, that's the independent variable comes on it, independent variable, and on the y-axis the response variable comes on it, which is also called as the dependent variable. This was the revision for yesterday. Okay. This was the revision for yesterday. Okay. Now we come on to today's topic. Okay. Okay. So what it is? Okay. So we have seen all these things. Okay. The one thing is there, caution. It is not appropriate to use the correlation to describe strength and direction for a linear relationship. Means what he is telling that it is not appropriate to use the correlation to describe the strength and direction of a linear relationship. We cannot
Mm-hmm.
say we cannot say every time by correlation about the
Mm-hmm.
strength of the two variables, about the strength or relation of two variables. Why is saying that? You will give some example below. Strength or relation of two variables. Okay. So what's the thing? See, we have seen this thing here. So exercise figure 3.3 shows six scatter plots that correspond to various values of R. To make the meaning of R clearer, the standard deviation of both the variables in this plots are equal. Okay, the standard deviation of both the plots are equal, and the horizontal and the vertical axis scales are the same. The correlation R describes the direction and strength of the linear relationship in each scatter plot. Figure 3.3, how correlation measures the strength and direction of the linear relationship. When the dots are tightly packed around the line, the correlation will be close to 1 or -1. We have seen this. Okay. Guess the correlation. You can see what will be the correlation of this data. Wait, looking at the graph.
The
What it
correlation, it seems weak, is negative weak correlation.
correct. And it will be weak correlation. Okay, yes, that's good. Okay, now next on to some things. Okay, there's a thing given here, and he has asked some questions. Interpret the value of R. So interpret means we have to comment about the value of R. Okay, so what will be the value of R? Here he has given. So what can you say about the value of R? What will be the correlation then? I'll take this example onto our board. Looking at the value of R, what can you say
Mm-hmm.
about the correlation? I've given the bifurcation for size. The value of R is 0.613, 0.613. So what can you say? R is the correlation. First of all, the correlation is positive, then in positive there were three types. What it will be? Moderately positive. Yes or no?
Yeah.
Yeah. So that was the interpretation. So we'll see what he has written. See. Payroll and number wins is moderate, strong, and positive. Moderate, strong. Strong means what? And is it linear? Yes, it's linear. Okay. It is linear association. It is also positive, linear, moderately strong. It is weakly strong or moderately strong. We say. Okay.
Hmm.
Okay. So then that was the answer for it. Okay.
That is
Okay.
weak negative correlation.
Okay. The scatter plot of shows the 40-yard dash lines. Weak knots, right? Weak. That's not weak. It's near above C in this dash in this
Oh yeah,
data.
there's some connection. So yeah, it's
It's
moderate.
minus 0.8. The value of R is given there. We cannot say it as weak. The value of R is very strictly minus 0.8. And I've told you the region where we have to say weak and where we have to say moderate and where we have to say strong. Wait a minute, I'll highlight that thing. Okay. So here the value of R is minus 0.8. Yes. So it is near about to
Mhm.
minus 1. Yes or no? So it will be strong,
Yeah.
strong, negative. I've told you if it is between near about minus 1 to 0.7, then it is strong, correct? So 0.7, minus 0.7 to minus 0.4, then it is moderately strong. And less than minus 0.4, then it's weak. I've given you this start upwards. Yes or no? It
Mm-hmm.
will be it will be strong, then negative, and it will be linear correlation. Linear, as line can be drawn. There is no curve. We can see that a line can be drawn. This is in a straight line. Yes or no? Linear. Okay.
Mm-hmm. Yeah.
So that's the thing. Interpret this value. So we'll move on to the next thing. Yeah. Okay, cautions about correlation. There are some cautions that we have to take while commenting and interpreting the results about the correlation. So what he wants to say is that while the correlation is a good way to measure the strength, we are measuring the strength of the two variables by correlation and direction of a linear relationship. And we can also comment about the relationship of the direction, whether it is positive or negative, whether x is increasing and y is decreasing or x is increasing as well as y increasing. It has several limitations, but it has several limitations. What are the limitations? Correlation does not imply causation. In many cases, two variables might have a strong correlation, but changes in one variable are very unlikely to cause changes in the other variable. For example, he'll explain it further. See, another variable. Consider the following scatter plot showing total revenue generated by skiing facilities in the United States and the number of people who died by becoming tangled in their bed sheets in the 10th recent year. What is skiing facility? I'll search about it. Just a minute. I don't know about the skiing facility. Skiing facility. You get enough idea. Oh, sky areas have marked paths for skiing known as runs, trials, or pistes. I see the name. Skiing facility. Oh, it's okay. This skiing. Okay. Skiing facility. Okay. And what he's telling that many people, skiing facilities. This graph. What I'll do, I'll take this thing. Interesting exercise about correlation, and correlation is very much interesting for me.
Maybe.
Okay. So what he's saying is trying to say that. Okay. So this relationship is revenue from skiing. The in the IC region, the people generally perform skiing for enjoyment. Okay, and these are the on the y-axis. The people are listed who died because of that the bed shift that happens in the icy region. You know how the landslides of ice are going on in the
Mm-hmm.
icy region. So these are the deaths. Okay. So the correlation for these data is 0.97. So it is 0.97. So what can we say about this? Interpret the result about the correlation. It is positive. It is very strong. Yes or no? Strong.
Yes.
And it is also linear. Yes or no?
Yeah.
Yeah.
I
So
agree.
what question is asking? Does an increase in skiing revenue skying revenue is increasing, okay? Cause more people to die by becoming tangled in the bed sheets. That can we say this? Likewise, if for suppose more tourists are coming to USA, more tourists are coming to USA are coming. So they
Mm-hmm.
will enjoy all the facilities and all the unique things in USA. Yes or no?
Yeah,
So if skying revenue increases, skying revenue
that's
increases,
it's
can
skiing,
we
not skying.
okay skiing sorry skiing
Yes.
says, revenue increases, skiing revenue increases. So can you say that the number of people died will also increase?
Yes.
By, yes, we can say by positive, as it is a positive relationship, but it's not that
Almost
true because we
perfect.
can doubt it.
It's a strong one.
Yes, but we can doubt it because skiing revenue does not directly imply that number of died people. Yes or no? Means what if 10 people
Yes.
are skiing, so it will not imply that one will die only. It can happen that if
Mm-hmm.
10 people are skiing, it can happen that no one dies. If 100 people skiing, then it can happen that zero dies. So this can happen. So here
Mm-hmm.
it can be
Yeah,
a doubt.
that is true.
Yes or no? There is a strong relationship between it by the graph, but there is a doubt. So we cannot interpret the results. Here, does an increase in skiing revenue cause more people to die? No. Okay, it does means it depends upon the revenue, but it will not what you say cause more deaths, more people to die because it is a natural phenomenon. Okay. Even though we shouldn't automatically conclude that there is an cause and effect relationship between two variables when they are an association. So we cannot say that direct there is an direct relationship and always there is an relationship where an association is very high, means positive. In some cases, there might actually be a cause and effect relationship. Cause and effect means what? Cause and effect. What can be an cause and effect relationship? Cause and effect. What does this mean? Depending something
Something affects
that
the other than
yes, something that effects by some natural phenomena, by some
hmm
natural
natural
phenomena. Yes or no?
phenomena.
Yes, natural
Yes.
phenomena. Because the bed sheets that the line slides happen there and the people die, it can be due to some natural phenomena that's going on there. Okay, it can happen in a next year that there are zero deaths due to it. Okay, so we'll move
But there
further.
could
So
also
you
be a surplus of debts as well.
correct. Yeah, it can be a surplus. It can be more deaths there can be. So it is dependent upon the
Mm-hmm.
natural phenomena. So we cannot conclude that in skiing revenue, if it is more, so the number of deaths will be more. Okay. So this was the thing that we have to be cautious about. So now there's a good topic. It's correlation and regression applets. That's a good thing that we have onto. So I think okay, we need to read this. So just read this. I'll bring some water.
Hmm.
Okay. Okay. So I'm back there. See? So in this activity, we use an applet to investigate some important properties of correlation. So what he is trying to do is that, okay, I'll take this on my notes. This is an interesting thing. We will be doing this in our uh, further logistic regression on in all that also. So what he is doing that we have 10 points. Okay, we have,
Mm-hmm.
for example, we have 100 points. Okay, 100 not. What he is telling you are going to use the correlation regression applet to make the several scatter plots that have Just start by putting 2 points on. Okay, so we have 10 points. Okay, so 10 points in total. So I have to put the, for suppose the, for this 10 points, the date, the correlation comes to be 0.4. So now what I have to do, I have to plot the points one by one, such that the correlation must be 0.7. Okay, such that the correlation means must be 0.7. So what I'll do, I'll plot this point and this point, then measure the correlation. How much is the correlation? Okay, 0.7. Then I look for the third point. So I'll adjust the third point such that it comes on to this line. Some point is here, so I'll adjust the line so that it is equidistant from those 2 points, that such that the correlation of the line is 0.7. So this what we are doing
Mm-hmm.
when we are adjusting the correlation to a specific value. Okay, it is called as regression. It is called as regression. Okay, so see, start by putting 2 points on the graph. What's the value of the correlation? Now we'll calculate the value of the correlation. Why does this make sense? Make a lower left to upper right pattern of 10 points with correlation about 0.7. So we need to take the 10 points such that the line which is drawn has a correlation about 0.7. You drag points up or down to adjust the R after you have 10 points. So we can drag the point up and down depending on the value such that the value of R must be 0.7. Making a new scatter plot this time with 9 points in a vertical stack. Now what we'll do, make a new scatter plot with 9 points only, such that the 9 points lie on the R such that it has the value 0.7. Okay,
Mm-hmm.
you can now 9 points on the vertical stack, add 1 point far to the right and move it until the correlation is close to 0.7. So we'll add it on to the right hand side, extreme right hand side, and move this such that it comes on to 0.7. Make a third scatter plot, this time with 10 points in a curved pattern, like this, for suppose, curved pattern. Okay, it can be like this or it
Mm-hmm.
can be like this, anything. Okay, so curve pattern that starts at the lower left and rises to the right. That starts, yes, starts at the lower left and starts. This one is talking about this one. Okay, so adjust the points up or down until you have a smooth curve with correlation close to 0. So adjust the point. For suppose in this thing, it is coming like this. It is coming like this. So what we have to do, adjust all the 10 points on this smooth curve. Adjust all the 10 points on this smooth curve such that R is again 0.7. So what does it do? Summarize, if you know only that the correlation between two variables is 0.7. What can you say about the form of relationship? So what will be the form of relationship? We'll see how he has commented. So we can say that the relationship is positive. Yes. Yes or no, Tej?
Mm-hmm.
As
Yes,
it is
definitely.
0.7. So that's the thing of regression. Okay. The activity highlighted some important cautions about correlation. Correlation does not measure form. Form means what is the form of the data. Here is a scatter plot showing the speed and the distance needed to come to complete the stop when a motorcycle brakes was applied. The association is clearly curved, but the correlation is quite large. R equals to 0.98. In fact, the correlation for this non-linear association is much greater than the correlation of R equals to 0.613 of the MLB payroll data, which had a clear linear association. So correlation should only be used to describe linear relationships. So we cannot tell. Remember, we cannot. What you will say? We cannot comment about the strength. Comment about the strength of relationship. What he generally needs to do, because we are going to study regression, and in regression there is a algorithm known as machine learning that is very that is in form in nowadays. So what does the regression do? It does generally a task of this. What we have done here, bring all the points onto one line. Okay, and correlation does not do this. Correlation only just plots a line according plots not does not plots a line also, but generally seeing the points and its association just tells about the value of it, likewise 0.9. So depending on this,
Mm-hmm.
we cannot say, we cannot, we cannot predict the future. We cannot predict or give conclusions about the future. That in future, that for example, we have seen the skiing revenue, the that the increase in skiing revenue will will increase the
But
debts.
that's
Yes, we cannot do this. We cannot do this task by correlation. We cannot do this task by correlation, because there is a term known as regression, and it has various terminologies in it. Regression is not small, correlation is very small, but regression has various terminologies stored in it. We need to do different tasks in it, then we can tell, then we can comment about the data that needs to come further. Is it clear, thing?
Yes, it's very clear.
Okay, what, yes, what about the correlation and strength and all that? Okay, so now this is the
Mm-hmm.
chocolate, chocolate one example. You read it. Most of the people love chocolates for its great taste, but does it also make you smart? Does it also make you smarter that you love chocolate? A scatter plot like this one recently appeared in the New England Journal of Medicine. The explanatory variable is the chocolate consumption per person of a sample. The response variable is the number of Nobel Prize per 10 million residents of that country. So what we are generally seeing is that, I'll take this on the board. Okay. So what we'll do, what he's telling that, for suppose this is X and this is Y. Okay. So this is for suppose
Mm-hmm.
it is chocolate consumption. Chocolate consumption. At this chocolate consumption, what he's telling that chocolate consumption, does it imply that the wise people, the Nobel Prize people, are more in that country, more in country? If the chocolate consumption is more, that Nobel Prize people is also more. Does this imply this? Can we say from? Can we say this? Can we say this by correlation? Yes or no? This is the question here generally. The explanatory variable is the chocolate consumption. So this will be CC, and this will be the Nobel Prize winners per country in specific country. Okay.
Yeah,
Okay. So this was the thing. So
a
these
million
graphs will be
residents
given
of
here,
that
I think.
country.
Yes, I'll
Huh.
copy this here.
So
Can
it
we? Okay, the
looks
question is
like
very clear. If the people in United States started eating more chocolate, could we expect more Nobel Prize to be
not
awarded to the? No, no. Come on, tell me the answer.
there there's a pretty strong correlation though, since it's pretty good, but mm,
Yes. There is a
yes, you
strong
could say that.
relationship.
It does
No, no, I've told you,
there's
correlation does not predict the future. Yes or no, they, we have just
yeah,
seen.
that's true. So I no, I don't think the chocolate does affect the Nobel
Correct.
Prize
Yes.
winners.
So how can chocolate affect the Nobel Prize winners? Yes or no?
It it can't really unless the chocolate somehow gives you smartness, but that's not really
Correct.
possible.
Yes, that's not possible. So the, if, though you have told correct, though correlation is very high, correlation is high, but we cannot cannot say that eating more chocolates, more chocolates in a country will increase its Nobel Prize, will increase the Nobel Prize winners, the Nobel Prize winners. Yes or no? What effect does Switzerland have on the correlation? Explain. What effect does Switzerland have on the correlation? So where's Switzerland here? I think it's here. Okay. So you can see that there are higher consumption of chocolate here. Yes, as well as there is a higher Nobel Prize winner in Switzerland also. Yes or no? So what he has commented, we'll
Yeah.
see. B. When Switzerland is included with the rest of the points, it makes the association stronger, but it doesn't vary much from the linear pattern. This makes the correlation closer to 1. So if, for example, see the data points are generally here, yes or no, in this line. And
Mm-hmm.
this Switzerland is away from this line, yes or no? So if we remove
Mm-hmm.
Switzerland, then it will be more near to 1. As R is for suppose 0.89, then if we remove that Switzerland point, as it is very strongly related, so it will be more clear to 0.97 something, closer to 1. Okay, this was the thing.
Mm-hmm.
So now on to the next, calculating correlations. This is one more thing, how we have calculated standard deviation. You know how to calculate standard deviation. Do you
Yes,
remember
and
how that is
deviation
done?
is the square root of
Yes, very good, very good.
mean
Square root of
HI
summation
minus
xi minus x bar the
my
whole square upon n minus 1. Yes or no?
yes. Yeah, that's
Yeah,
it.
that's the thing. That's the thing. Yeah, yeah. So now there's a formula. for correlation also. Online online I'm saying, sorry. So there is a formula for correlation also. Okay. Formula for correlation. So what's the formula? See what it is. R is for the correlation. So we have seen, right, that thing. What was the Z score? Z score was xi minus x bar upon standard deviation. Yes or no?
Yeah. So this
Divided
bit,
by the
yeah.
standard deviation. Correct. So this is something like that only. Taking
Mm-hmm.
1 point, okay, taking 1 point, then what we do, for suppose there are x1, x2, x3, x4. This is suppose column 1 and this is suppose column 2. Data points y1, y2, y3 and y4. Yes or no?
Four. Yeah.
So what we need to do for calculating the correlation, what is the formula? We generally take, see this here, he has listed here. What is suppose that we had data on variables x and y for n individuals. The values for the first individual x1 and y1, the values for the second individual x2 and y2, the mean and the standard deviation of the three variable n. So what is x? So I'll write it here. So the x in the formula, in the x and y in the formula, so the x and so the x and y in the formula are the means
Yeah.
of column 1 and column 2 respectively. Means what? The mean of this column 1, summation x bar, sorry, summation x bar, I'm writing x bar, mean is x, and y bar is y. Yes or no?
Yeah.
This will be the mean. So what we need to do, take x1, we'll subtract it from x bar and divided it by sx. Okay. For what we'll do for
Mm-hmm.
y, y1 minus y bar, or we can also say y because we have listed down there. Divided by standard deviation. We need to calculate the standard deviation of column 1 and name it as sx, and standard deviation of column 2 name it as sy. Divided by this, and then what we need to do, multiply both these columns. Okay. Then this
Yeah.
multiplication of this will be here. Okay. This multiplication x1 minus x upon sx into y1 minus y upon sy. Now what we need to do, calculate for each one, two, and this four. This one multiplication will be here, multiplication will be here, multiplication will be here. These will be all numerical values, and we need to add this, and we need to add this. So we'll get a summation here. What will be the summation? Summation of xi minus x bar upon summation x, yes, sigma x sx we can say, into yi minus, why we write I, because I is an subscript variable which is running from 1 to the number of data points in the set. Yi minus y
Mm-hmm.
bar, or you can say y upon sy, standard deviation of y. This will be the summation, and when we divided this by n, we divided by n or n minus 1, n minus 1, same as it, n minus 1. So what this formula is for, all for, this is for r. Did you get that right? This is a merged formula,
It's
and this was a, what you'll say, descriptive formula he has taken for n values, dot for n values. I have merged all those into the summation side. Yes or no?
yeah.
Yes. So see, this is a
Really?
compact.
Yeah.
This is the compact of this. Okay. Okay. So this is the formula for correlation. How we need to calculate the value of R for a specific table. So this Angelus Dodgers, whose payroll was $274 million and who won 91 games. So what we need to do, scatter plot showing the relationship between payroll in millions of dollars and the number of wins of major 30 league baseball teams in 2016. The point representing the Los Angeles Dodgers is highlighted in red. Okay, so this is the representative of data that he has given that here for the Los Angeles Dodgers. Okay. So the formula for R begins by standardizing the observation, the values. So where does the formula begin? Okay. For suppose what he is saying that this thing in this formula, what is this? What is this? Can you say this is the Z score for X? Yes or no?
It's-
Yes. And this is the Z score for Y. Yes or no?
Mhm.
Yeah. So what's the main the formula of R? What he is suggesting is that it is I running from 1 to n. It is Zx into Zy, summation of all the column Z score divided by n minus 1. Yes or no?
Yeah.
That's the thing, what he's trying to explain here in this example. Calculate the Z score of each and every value, then multiply it. Then what we need to do, divide it by, see, he has calculated ZY here. Now what we'll do, see here, we have multiplied. See, it was the value of ZX was 2.75 and ZY came to be 0.95. So we multiply 2.75 into 0.95, it came to be 2.6125. Now we'll divide it by n minus 1. So how many sample was there? What was the size of the sample? I think it was 91 games. Okay, na? So it will be divided by 90. So when we'll divide 2.6125 by 90, so it came out to be 0.613. Yes or no? So this is the correlation value. So what will be the correlation? It will be moderately positive. Yes or no? Moderately positive. Yes or no about this correlation?
Because it's greater than 50%, but then less than
Correct.
70%.
Correct. 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 That's good to say. That's good. Okay. So scatter plot showing the, you can do these examples, read this very clearly and understand it. If there is any difficulty, you can tell me. Okay. Additional facts about correlation. So know that you have seen how the correlation is calculated. Yes, we have learned or not how it is calculated.
Hmm?
Uh,
Yeah,
shall we do
we
one
learned
example
about
or
that.
it is very easy, I think the calculation of, there is no need of in your textbook, there in your exams also there will be no sums on calculating the correlation by this method, but just he has listed the formula here. Okay, if it is there we will do it one example also. Okay, first of all we see
Hmm?
the additional facts. Correlation requires that both variables be quantitative. First of all, this is one important point for correlation. For correlation, mm, I'll keep it there. For correlation, it is important that correlation both x and y are quantitative variables. Are quantitative
Variables.
variables. Yes. First condition for correlation. Then so that it makes sense to do arithmetic indicated by the formula for R. Yes, we have the formula for R in numerical sense, so it is very important for it to be in numerical. Okay, then
Hmm?
between, we cannot calculate the correlation between incomes of a group of people and what city they live in. Yes, it cannot be.
Hmm?
It cannot be one. It cannot be. It cannot be one quantitative and other categorical. It cannot be calculated. Correlation cannot be calculated. Correlation cannot be calculated. Yes or no? Yes, that's the thing. Okay. So this is the thing. Correlation. When one or both of the variables are categorical, use the term association rather than correlation. When what he's saying that when one or both the terms of the variable are categorical, you can use the term correlation. You can use the term association. So what we can do, we can plot an association graph between the categorical variables. For example, what I can take sales of a specific ice cream. For I'll say it's a chocolate flavor ice cream, chocolate. It's a vanilla flavor ice cream, and it is a, for suppose, strawberry flavor ice cream. Okay. So in summers, whose sale is more? So for suppose this is chocolate flavors ice cream sales. Okay. This is a vanilla flavors ice cream sales, and this is a strawberry flavor ice cream sales. So what you can see that it is an increasing graph. Yes or no? So it will be a
Yes,
positive
increasing graph.
association. Positive association. Okay.
Hmm?
So because R uses, okay, correlation makes no distinction between explanatory and response variable. I've told you this distinction. We cannot make the distinction between those variables when calculating the correlation. It makes no difference which variable you call x and which variable you call y. Means you can take column one as also column one as x, column 2 as y, or column 1 as y and column 2 as x. It does not affect the r value. It does not affect the r value. Did you get got that, Zed?
Hmm?
Yes.
Yeah.
So because r uses the standardized values of observation, we have seen what is r. What is r? Remember this basic formula: zx into zy divided by summation of n minus 1. Okay. So this is the thing.
Mm-hmm.
So R does not change when the change of units measures X of Y or both. Means R does not change when we change the units of measurement. When we change the units of measurement of X or Y, it does not change. The correlation between height and weight won't change if we measure height in centimeters rather than inches and measure.
Which
Means what?
is
Means what? If I'm taking height and weight and I'm seeing the relationship, interrelationship, and first I was measuring height in for suppose centimeters and centimeters and weight in for suppose kg. And now what I have done
mm-hmm.
frequently that I have plotted the height in inches and remain the weight in kg only. Okay, so the relationship the in the previous task was this, and when I have changed the what you'll say the uh, what you'll say that the quantity, it will not change. The relationship will be the same, and the value of r also will be the same. Did you got that? Right?
Yeah, I got that.
Okay, the correlation r has no unit of measurement. So as we measure rice in kgs, but there is no unit for R. It is a unitless quantity. It is a unitless quantity. Did you got that right? All the facts about
Yeah.
R. You need to list it down in your notebook so it will be better remembered to you further. Okay. So you can do this
Mm-hmm.
example. Okay, come on. We'll do this and finish. Call our day to our end. Okay. The following scatter plot shows the height in inches and the number of steps needed for a random sample of 36 students to walk the length of a hallway. So there's a hallway in the school, and depending on the height, what number of steps do they require to reach the hallway? The correlation is R equals to minus 0.632. So whether it is what is the interpretation of the correlation? It is a moderately negative correlation. Yes or no?
Mm-hmm. Yeah.
Yes. So explain why it isn't correct to say that correlation is minus 632 steps per inch. Why it is not correct to say it is minus
Because
632
it's varied.
inch?
It's varied between the steps. It's
Correct,
not a
correct. We
clear
cannot,
correlation.
yes, I'm telling you, we cannot give any conclusion depending upon the correlation.
Mm-hmm.
The conclusion comes from regression, not from correlation. Okay. So what here see, because
Yeah.
correlation is calculating using standardized value, it doesn't have units. Here see, this was also a step that he has given steps per inch, and correlation does not have a unit. Yes or no? We have just studied it further. Yes or no?
Mm-hmm.
So this will
Yeah.
be the correct reason
Exactly.
that as correlation does not have any unit and he has given a unit here, therefore it's incorrect. What would happen to the correlation if the number of steps used was explanatory variable and the height was used as a response variable? So we have seen if we change the explanatory variable and the response variable, if we interchange also, the value of R does not change. Yes or no? We have seen it further. Yes or no?
Yes.
Yes. What
Yeah,
would happen to the
exactly.
correlation if height was measured in centimeter instead of inches? I have given you this example also. It will not affect the value of correlation. Yes or no? Yes.
Yeah,
So the
I
answers
believe
will be
so.
set
Yeah.
down. Okay. Now that's the end. Alhamdulillah, we have ended with our section 3.1. That was correlation. We have
Mm-hmm.
gone through several topics such as scatter plot, exploratory variable, response variable, then association about the positive association, negative association, no association. And we have seen that measuring of association is also called as correlation. And correlation ranges from -1 to +1. And it also has three types: strong, moderate, and weak. Yes or no? And when the value of R is
Yes.
zero, we say that it has no correlation. And we have seen some important things about the correlation. Yes or no, Zaid?
Yes.
Okay, so this is some exercise. It has some sums. You need to solve it in your homework. And if you have
Mm-hmm.
some difficulty, you need to get back to me. Yes or no? Here you can see in
Yeah.
this
Okay.
graph, I'll just comment about this graph. It will have no association and no correlation. Yes or no?
Yes. Mm-hmm.
Yes. Okay. So you need to do this exercise. You do it, practice it. Okay. Then from tomorrow, we'll
Mm-hmm.
start with least-square regression. There comes the regression thing, all about
We
fitting a
have a
line.
class at 8 p.m.
Yes, correct. 8 p.m. I'll take the class. Okay. So we'll
Oh
join.
yeah,
You'll join at
you're
8 p.m.
tomorrow.
Yes.
By today.
Okay. Okay. Yes. Yes. 8 p.m. By
Yes.
today we have by for you it will be today. Yes or no?
Yes.
Yes, 8 p.m. at today. Thank you. Okay. Sir. Assalamu alaikum. We'll start today
Walaikum
with least square
salam.
regression.
Okay,
Okay,
got it.
yeah, left.
That's all